Hey, today we are learning about curve sketching. So we're taking all the skills we talked about in the previous videos, and we're going to actually go ahead and do the application. We're going to actually see what it looks like. So what's the goal today? I can use the skills learned in the previous units, and that's specifically Unit 3, and courses, which is grade 10 and grade 11, to develop a sketch of the following functions. So what we want to be able to do is we want to be able to accurately sketch this cubic. All right, so everyone has a different starting point, and it doesn't really matter the order you find information. I always like finding first and second derivatives right away to get that sort of out of the way or out of my hair. So I end up with 3x squared minus 4x minus 11. And the second derivative, polynomials are always nice, 6x minus 4. So there we go. So there are my, I'll kind of do this in red, f prime of x, f double prime of x. So if you have kind of a mental checklist as to what you need to do. Next, let's talk about asymptotes. So my vertical asymptote, none. Okay, the reason, no denominator. You can only have a vertical asymptote if you have restrictions. I don't have a denominator to create restrictions, so I have my vertical asymptote taken care of. Horizontal asymptote or the slant, okay, none. Same reason, if we don't have a denominator, we don't have to worry about the asymptote. So those two are taken care of. All right. Where do you want to go next? Max min. So if we look at our max min, so the max min value, we let f double prime of x equals 0, f prime of x equals 0. So I have 3x squared minus 4x minus 11 equals 0. I'll quickly check to see if I can factor here. So 1 and 3, 3 and 1. It's a complex trinomial. Do any of those combinations give me 4? 11 and 3 won't work. All right, 11 and 3. Oh, and 33 and I thought that might have worked, but anyway, if it doesn't jump out at you right away, then you go to quadratic formula. So anyhow, so x equals, and I'll write out the quadratic formula, b squared minus 4ac 2a. So we'd have 4 plus or minus negative 4 squared minus 4 times 3 times negative 11 all over 2 times 3. So if this ends up being a messy number, you kind of got to leave it as is and work with what you got. But inside, I end up with 16 plus, because we have two negatives, 11 and what do we got? 120, 132, I believe. 132. And on the bottom, I'm going to have a 6. Just Minecraft. Sorry about that. So we got 132. So that means I have 4 plus or minus the square root of 8, 148 over 6. Now we're going to have to work with this. So this is where your approximation skills come in. Square root of 148. We know that the square root of 144 is 12, so it looks like close enough to 12 for me. And yes, you're allowed to do this. It's an approximation. You don't have a calculator, so I allow some rules to be bent here. So we end up with 4 times 12, 4 plus 12. So that's 16 over 6, which reduces down to 8 over 3, or negative 8 over 6, which gives us negative 4/3. And again, we have an approximation. So I'm going to put that from about this point on. It's an approximation, and I know that. And like I said, don't have the calculator, so you're allowed to bend some of the rules. So therefore, max slash min at x equals 8/3 and -4/3. Okay, so we got that. We know the locations of our max mins. Coming back to the top here, let's do x and y intercepts. So our x-intercept, so let's put that in red. Okay. This is when we let y equals 0. 0 equals x cubed minus 2x squared minus 11x plus 12. How do we determine if we have a factor? This is where you need to use your factor theorem. So underneath, what happens if I substitute a 1 in? So I would have 1 take away 2, take away 11, plus 12. So that would be 1 take away, whoops, should be a 2 there, sorry. 1 take away 2 is -1. Take away 11 more is -12 plus 12 is 0. So therefore, x minus 1 is a factor. So we're using our factor theorem. So what does that mean? It now means that when I go to my long division, or synthetic division, I can reduce this down a little bit more. So we're adding here. So -2 plus 1 is -1. That's -12. That's 0 remainder. So it means I did it right. So therefore, x cubed, oops, therefore 0 equals x cubed minus 2x squared minus 11x plus 12. That's the same as x minus 1 for my factor. And now I'm left with x minus 1. Oops, can't get that aggressive here. X minus 1x minus 12. And that factors down even further for us because it becomes out to be x minus 4 and x plus 3. So therefore, we have x-intercepts at x equals -3, 1, and +4. So there are the x-intercepts taken care of for us. Continue on. Let's do the y-intercept. So your y-intercept, let x equal 0. So that means that y is going to, I'm not going to write it all out, y equals 12. So therefore, let's go with a y int at 0, 12. So now we have our y-intercepts. What else is on our checklist? Inflection point. Okay. We could do inflection point as well. So that's an IP. So I know that there's an inflection point when the second derivative is equal to 0. So we set the second derivative equal to 0. Second derivative was 6x minus 4. So 6x equals 4. X is 2/3. Therefore, an IP at x equals 2/3. And what else? We can do some end behavior, I guess, as x goes to infinity. So we'll just do extra space here. So end behavior. So our end behavior, the limit as our function goes to -infinity for f of x, and the limit as x goes to infinity for f of x. So just looking at this, how you're asking yourself, well, how do you do this? You go back to basics here. This is a positive cubic, so you know a positive cubic is going to have that general shape. So as it goes to -infinity, it's going to become very, very negative. As it moves to positive infinity, it gets very, very big. So you're just doing it what I call by inspection. So it goes to -infinity and positive infinity. So there we go. We have a whole bunch of information now. Now we need to go ahead and put it on the sketch. So I think the next screen's a graph for me. So I start putting on information. And let's go up by um, probably by 5s on my y-axis. And on the x-axis, I don't think there was any x values that got ridiculous. If we look back at all our x values, x-intercepts, where did they go? Right here. It's got to go up to 4. So let's go by 1s. 1, 2, 3, 4, 5. All right, so we start plugging in the information we do have. This is a little bit easier for you than it is for me. No asymptotes, x and y intercepts. I can put those on. -3, 1, and 4. So put a nice dot there. -3, 1, 4. Okay. Scrolling down here. Y-intercept at 0, 12. There somewhere. All right, and inflection point at 2/3, x equals 2/3. Now the problem with this is nothing's ever perfect when you go through and do this. So what I always tell people, again, it's approximation without the calculator, and I'm not going to be too picky with this. I know my max min occurs when x is 8/3. Well, it's already an approximation, so I'm going to kind of see that as it's pretty close to 3. And -4/3, we can call that -1, just to give us a general shape. I mean, if you have a calculator, this is simple. You don't have a calculator, make the numbers easy. So we got to substitute those values back into the original function. So we got to take that -3 and we got to plug it into this equation. All right, so if you put the -3 in, and we'll just do it above, so we end up with -27, it'd be 9 times -2, so we have -18. Here we'd have positive 33 plus 12. So that's going to give us an approximation as to where that max occurs. So -27 minus the 18, -45. Add 33 to that, so you get 12 plus 12, so it's about 24. All right, so you're just doing some simplifying math. So at -8/3, so just short of 3, it's up at about 24, I said. Okay. Doing the other one. So again, I said approximately -1. So let's plug in approximately -1. So we'd have -1. Here we'd have -2. Here you'd have +11, +12. And I think I crossed that up. Which was the negative here? It's +3. That changes the previous one just a little bit. That'd be a positive. That becomes a negative instead. So now that goes to +3. So that would be 35, 45, 24. And just a second, some of the. All right, so like I said, I made a bit of a mistake there. This should still be negative, though. Yeah, so that works out all right. So 27, take away 18, gives you, what would that give you, 9? So you got +9, and we add that to 12, that gives you 21. 21 from 33, so that's about -12 roughly. So my mistake when I plotted that point, it should be at +3, and when I say -12, so down here somewhere. And then when you plug -1 in, so I'm doing that in the red, okay, you end up with +20. Again, it's an approximation. I'm kind of rushing through it. So -120, you know it's going to be a little bit more because there's a little bit more than that anyway. So now you ask yourself, well, I already know the general shape of a cubic, so I have enough information to connect the dots. So do I have to do any of the other steps? No, because I'm not looking, can I make you do all the steps for a particular function? Hey, can you give me enough steps to accurately sketch it? So I'll leave it at that, and we'll move on to the next example.